Critical numbers and critical points. A number C, and this is important, in the domain of f of x is called a critical number if either f prime of c equals 0, the derivative is 0, or f prime of c does not exist. The corresponding point, c f of c, on the graph is called a critical point for f of x, relative extrema. Max, min? That's what they mean by extrema. Can only occur at critical points. Guidelines for finding intervals on which a function is increasing and decreasing. Let f be a continuous function. We don't have to worry about that in this class. To find the open intervals on which f is increasing and decreasing, use the following steps. Find the critical points of f in the interval and use these numbers to test intervals. Determine the sign of f prime in one test value in each interval. Use theorem, blah, 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 determine in increasing. I mean, that's the whole thing with this theorem thingy-poo is, I think I just recorded that. Oh, God. Anyway, the theorem means that if f prime is positive, increasing, f prime negative, decreasing, f prime 0, constant, that kind of thing. But this is what it's really saying. Any and, take the derivative set equal to 0. So these guys get my critical numbers. Solve for x. How do you find critical values? Take the derivative, set it equal to 0, or where f prime of x does not exist. Now we'll talk about that when we get to it. Right now we've got things that exist, and I'll show you why something would not exist when we get to a problem. So what it says, find the intervals of increasing or decreasing. Take the derivative, set it equal to 0. That gives you your critical numbers. So f prime of t equals 3t squared plus 6t set equal to 0. So 3t times t plus 2 equals 0, t equals 0, t equals negative 2. These are your critical numbers. So on my number line, I put my critical numbers. Negative 2 and 0. Now what it tells you to do, and we're going to focus a little bit more on this as we go through. I have some stuff online with the multiplicity. But what you do is, I want to know, where is f prime positive, f prime negative, and I know where f prime equals 0. It's at negative 2 and 0, right?
Yeah.
So f prime of x equals 3t times t plus 2. Easiest way to do it. Second easiest way to do it. Pull a test point. T equal negative 3. Is f prime positive, negative, or 0? F prime of negative 3 is 3 times negative 3 times negative 3 plus 2, which is negative 9 times negative 1. Positive or negative? Positive. I don't care what the number is. I just want to know what the sign is. So that says f prime is increasing. If he's followed by decreasing, then negative 2 is a maximum, right? So, pull a test point, negative 1. F prime of negative 1 is 3 times negative 1 times negative 1 plus 2, which is negative 3 times 1. Positive or negative? Negative. Here, F prime is decreasing. Pull a test point, 1. F prime of 1 is 3 times 1. 1 plus 2, 3 times 3, positive or negative? Positive. Positive, negative, what's this guy? What is he? Max, right? Negative, positive, what's that guy? So, increasing, decreasing, moving from left to right, increasing from minus infinity to negative 2. That's wherever I have pluses, we're increasing. Decreasing from negative 2 to 0, and then increasing from 0 to infinity, wherever I have pluses.